Now, let's see what is the mechanism of Cannizzaro reaction. So here, benzaldehyde treating with a strong base like potassium hydroxide or sodium hydroxide. So, potassium hydroxide in aqueous solution that will exist as a K positive OH negative. So here the OH negative is a nucleophile. Nucleophile means the nucleus loving agent. So OH negative is looking for a positive charge. So when benzaldehyde is treated with the potassium hydroxide, what happens is the OH negative hydroxide ion is attacking on the carbon atom of aldehyde group. So here there is a possibility for the polarization because the electronegativity of the oxygen atom, the pi electrons moving towards the oxygen atom, and oxygen gets a slight negative charge and carbon gets a positive charge. So oxygen gets slight negative charge and carbon gets slight positive charge because of this electron negativity difference between carbon and oxygen atom. So in that stage, the nucleophile, the OH negative attached to the positive charge carbon atom. As a result of that, we will be getting CO minus because the negative the pi electron move towards the oxygen atom. And here the positive charge attracted by the OH negative ion. So here OH and the hydrogen is here already. So we have a hydroxyl group attached anion. So that's called, it's called hydroxy alkoxide. So in second stage, and this step is considered to be fast, very fast. In second stage, what is this ionic form or hydroxy alkoxide react with another molecule of benzaldehyde. So here C double bond OH C6 H5 CHO benzaldehyde. So here I would say this step is called, that's called first step, step 1. Step 1 is a nucleophilic attack, or the step may be called as nucleophilic attack. So here the first step involved a substitution or nucleophilic. The OH negative is called a negative ion is called a nucleophile. So it's called as a nucleophilic attack. And here, and then we got hydroxy alkoxide, and that combined with another benzaldehyde molecule. So that may be called as a step 2. Step 2. Here there is an important rearrangement or an important transfer taking place. That is, or shift is called a shift. So here, due to the presence of this benzaldehyde, here what happens is this negative charge, negative ion means 2 electrons. So the 2 electrons moved into the carbon atom. So there is a possibility for the formation of a double bond again. And at the same time, what happens is the H takes the bonding pair, and that is called a hydride. H negative is called minus H negative. It's called a hydride ion. It's called a hydride shift. The second step involves a hydride ion shift. Hydride ion shift. hydride ion shift. So here the same thing might happen, because due to the electronegativity of oxygen atom, this bonding pair might move to here. So oxygen might get slight negative charge and the carbon might get slight positive charge. So if that hydrogen moved as a H negative hydride ion, that H negative finally will go to the carbon atom. So what happened is, after this shift, that means first here the lone pair, the negative charge moved into the carbon atom and forms a double bond here. At the same time, the bonding pair shifted towards the hydrogen and forms a hydride ion, and that hydride ion goes to the carbon of carbonyl group, carbon atom of carbonyl group, C double bond O group. So here what happened is, we can write like that. There is a benzene ring and CO double bond here, and the hydrogen went away, and here OH. Then this part is here now. So here C6H5 C double bond O OH, plus here what happened, the hydrogen attached to the carbon atom, and the bonding pair moved towards the oxygen atom. So what happened is, here carbon O minus, and here H, and here H. So what is the next step is, the step 3 is the proton transfer. Step 3, proton transfer. That means the OH bond here, this is an acid form now. The OH bond here breaks, and the hydrogen will leave as a H positive, that's called a proton. So here minus H positive, and H positive transfer takes place, and that H positive, this bond breaks and the bonding pair move towards the oxygen atom, and the hydrogen will leave as H positive, and that H goes to the neighboring O negative ion. So what we'll have now, this one, what happened here, double bond O, no change, and here there is a O negative, plus what happened second molecule here. So here CHH bond here, CH2, because CH2, and there is a oxygen, and the hydrogen attached to the negative oxygen and becomes OH. So we'll got now C6H5 CH2 OH. That is called benzyl alcohol. Benzyl alcohol. I can write like that. CH2OH. That's called benzyl alcohol. And here an anion of an acid, because C6H5 COO minus, that is a benzoate anion. So this reaction taking place in potassium hydroxide medium. So this OH minus is used for here for nucleophilic attack, and the remaining potassium K positive attached with this O negative and forms, there is a K positive from potassium hydroxide and forms here COOH, K positive, mean K positive, CO minus, means so a potassium salt of benzoic acid. If it is a sodium, it's called sodium salt of benzoic acid. So here we have two products now. We start from here, benzaldehyde, and we got benzyl alcohol and potassium salt of benzoic acid. It's called potassium salt of potassium benzoate or potassium salt of benzoic acid. So here this benzaldehyde get oxidized into potassium salt of benzoate. So this step is called oxidation, and here is called reduction. So in same reaction we can see both oxidation and reaction. So it's called redox reaction, and this name reaction is called Cannizzaro redox reaction.